All right, let's dive into one of the biggest, most mind-bending ideas in all of science. We're going to ask a really simple but kind of radical question. Is dark energy even real? I mean, could one of the biggest discoveries of our time actually be a giant misunderstanding? Let's get into it. Just think about this for a second. We're told that dark energy makes up almost 70% of our entire universe, yet we have absolutely no clue what it is. So what if the reason we can't find it is because we've been reading the clues all wrong from the very beginning? Okay, so to really get why this whole idea is being challenged, you first have to understand the official story, right? How in the world did we get to a point where scientists believe most of the universe is this invisible, accelerating force? Well, it all kicks off with a concept called redshift. This is such a cool concept. You know how when an ambulance is racing away from you, the sound of the siren gets lower and lower? That's because the sound waves are literally being stretched out. Well, light does the exact same thing. When a galaxy is moving away from us, its light waves stretch out, shifting toward the red end of the spectrum. That's redshift. It's basically our cosmic speedometer. So this one observation, redshift, it just set off this incredible chain reaction. First, astronomers saw it everywhere they looked, and that confirmed the universe was expanding. But then, in the late 90s, they got a massive surprise. When they looked at these really distant supernovae, the redshift was way higher than their models predicted. The only explanation they could come up with? The expansion isn't just happening, it's speeding up. And to fuel that kind of acceleration, you'd need some new, mysterious force. And boom, they called it dark energy. Now, that whole story, it makes perfect sense, right? It's a clean, logical progression. But here's the thing. It all hangs on one single critical assumption. And some new theories are putting a huge crack right in that foundation. And this is it. This is the linchpin. The entire, massive 70% of the universe theory of dark energy is built on the idea that redshift is caused by one and only one thing: space itself expanding. For decades, this was the bedrock assumption. See redshift? You're seeing expansion. Simple. But what if that's just not the whole picture? What if there are other things happening out there in the cosmos that are also stretching light, adding to the redshift we measure? If that's true, it means our cosmic speedometer is completely out of whack. So this new way of thinking suggests there aren't one, but potentially 4 causes for redshift. We already know about space expansion, so let's check out the 3 new cosmic wrinkles that could potentially change everything we think we know. 3 pretty mind-bending possibilities that could be tricking us into seeing an acceleration that might not even be there. Okay, this first idea is a really wild one. It basically challenges one of the most sacred rules in all of physics. We all learn in school that c, the speed of light, is a constant. It never changes. But what if that's not quite right? This idea suggests that space itself might have a kind of stiffness or resistance that has actually changed over billions of years. Think of it like light traveling through water versus traveling through air. Its speed changes. If the fabric of ancient space was different, the speed of light itself could have been different back then. And that change alone could create an effect that looks exactly like acceleration, when really, it's just an echo of light's changing speed limit. The next wrinkle is just as bizarre. It suggests that it's not just space that might be changing, but the actual matter inside of it. So here's the critical part. We measure redshift by looking for the specific light signatures of elements, like hydrogen. We just assume that a hydrogen atom today is perfectly identical to a hydrogen atom from 10 billion years ago. But what if it's not? What if the constant expansion of space has subtly changed the fundamental size of atoms over eons? A slightly different sized atom would spit out a slightly different color of light, creating a fake redshift that has absolutely nothing to do with speed. And the third wrinkle, this one challenges our picture of a nice, smooth, uniform expansion. It says that space might be a much more chaotic, lumpy place than we've been imagining. Yeah, we tend to think of the universe expanding like a perfectly smooth balloon being blown up. This idea says it's more like a chaotic, bubbling pot of water. Imagine huge regions of space that are expanding, sure, but right next to them are other regions that might be locally contracting. If our line of sight to a distant supernova happens to pass through these uneven, dynamic pockets, it could stretch or squeeze the light in all sorts of weird ways, adding yet another layer to the redshift that isn't caused by universal acceleration. So you put all this together. If we entertain these possibilities, a changing speed of light, shrinking atoms, a lumpy, dynamic universe, what does that actually do to the whole theory of dark energy?
Well, our entire cosmic model has been built on this assumption that expansion is responsible for 100% of the redshift we see. But if these other three factors are contributing even just a little bit, then the amount of redshift left over that needs to be explained by acceleration, well, that amount starts to shrink. A lot. Maybe even down to nothing.
And this right here is the knockout punch. All that extra redshift that astronomers measured back in the 90s, the very evidence that forced us to invent dark energy in the first place, it might just be a cocktail of these other cosmic effects. If that's true, the evidence for acceleration itself just sort of melts away. And of course, if the acceleration isn't really happening, then the whole reason we came up with dark energy just vanishes. It becomes this beautiful, elegant solution to a problem that may have never even existed. Now, this doesn't mean dark energy is definitely wrong, but it forces us to step back and question everything. It's just a powerful reminder that in science, you have to keep questioning assumptions, even the really big fundamental ones. Because if we've been misreading the biggest signal the universe is sending us, just imagine what else we might find when we finally start looking with fresh eyes.